A common question that I get asked at least twice a year is how do you program a programming language? Who writes the programming languages? Well, it's an extremely good question. And the best answer is Bacchus Naur-Form, which is invented by two guys called John and Peter, I think his name was, and a number of other people, and they invented this Bacchus Naur-Form, which is a process for defining the syntax of a programming language. Basically, it's a way to write programming languages. It's how programming languages are written. And like Lego, it's quite simple. The underlying structure is quite simple, but it can be. You can build big, complicated, powerful things with it. And here's an example. So this first line, we are defining a letter. And we are saying a letter is defined as an A, or a B, or a C, or a D, and then the ellipses basically are the alphabet, or a Y, or a Z. These long strips in between each letter, these long vertical lines, they're called pipes, and on the keyboard, they are, on these keyboards anyway, they're they're next to the left shift button. There's sometimes a gap between them, though they usually come out as unbroken vertical lines. The syntax is quite important, so it's worth making note of the syntax, rather than using the word syntax in the syntax definition language. But yeah, so by that I mean, when you're defining a new thing, put the new thing in triangular brackets. So letter is in triangular brackets, followed by two colons, followed by an equals, and then put a pipe between each alternative possibility. So in this top row, we're defining what a letter is. So a letter is either an A, or a B, or a C, or a D, or any capital letter in the alphabet. So having defined letter, we can then use our definition of letter in our definition of word. And that's what's happening on the second line. So on the second line, we're saying a word is defined as being a letter or a letter followed by a word. Notice there's no pipe here between the letter and word, so it's a letter immediately followed by a word. We've defined letter already. We're in the process of defining word, and we basically already have defined word. So a word is either a letter or a letter followed by a word. What's a word? Well, a word is either a word. A word is either a letter or a letter followed by a word. What's a word? Well, a word is either a letter or a letter followed by a word. There's a sort of loop thing going on here. What type of loop is this? What is this? What is this definition? No, begins with R. What's that fourth type of loop that you will learn today as computing that nobody enjoys? Recursion, yes, well done. This is a recursive definition. We are using the word in the definition of word. Right. You can see what's going on probably easier than I can try and explain it. I think it's one of those things where the more I try and explain it, the more confused you become. A word is defined as a letter or a letter followed by a word. I mean, this is quite powerful. In the same way that, with recursion, it sort of breaks things down. So if I have a word like, I don't know, cat. So cat is a candidate word. This might be a word. We're not sure yet. Is cat a word? Well, in order for cat to be a word, it has to be a letter followed by a letter or a letter followed by a word. Is cat a letter? Well, it's not really. So it fails that first test. But is it a letter followed by a word? Well, it might be. It's a letter, definitely. So cat is definitely a letter. Is it followed by a word? Well, it might be. So if, that C is definitely a letter. If at is a word, then it passes the test. Is at a word? Well, we'll have a look. At might be a word. if it's a letter followed by a word. So in our next round, we have so we're happy with the C, that's a letter. And this, so if this next bit is a word, if act is a word, then we are happy that this is, that cat is a word. So, well, is act a word? Well, in order for act to be a word, it has to be a letter followed by a word. So, well, A is a letter, that works. T, is that a word? Not sure yet. Find out in a minute. You see where I'm going with this? Possibly. I think I might stop explaining it at this point, because I think the further I go, the more confusing it will get. But hopefully you should see that, so T is, we're happy that C is a letter, we're happy that A is a letter. If T is either a letter or a word, we'll be happy with that. And in the next round we'll discover that T is a letter, and then we can end, and yes. So that's how we can reuse it. So basically what we're saying is our definition of word can be either one letter, or it can be many letters. Yeah? Word consists of one or more letters. This is quite a useful, this little recursion trick here is very useful. Most of the examples, most of the exam questions that you get involve an element of recursion. If you get a question that says, define a thing where this thing can have one or more of those, then it will look, your definition will look very similar to this. If it was going to be 0 or more, then I guess you just start with a pipe. 0 or more letters, and you just start with a pipe. Or, so it would be either nothing, or a letter followed by a word. You'll see, and we'll do some examples later. So, this is Bacchus noir form. And this is one way of defining syntax. This is the most popular way of defining syntax. There is another way of defining syntax, using a syntax diagram. They are quite simple. They're simple to the extent that they probably don't actually require much in the way of explanation. Basically, you use a flow diagram, use something very similar to a flow diagram to establish your syntax. So in this case, whatever it is we're defining here, I'm giving it a name, but the thing we're defining is a letter, one letter, followed by one digit, followed by, well, maybe nothing, or followed by more digits. Or put it another way, in this definition, the thing we're trying to define has to have only one letter. It has two letters, it fails. It has to have one letter, at least, one letter, then at least one digit. Yes. If we were to say 0 or more digits, we could do it like this. The line going straight through. And then you have digit sort of on a separate bit. And then coming back. So, very simple, reasonably powerful. You can do quite a lot with these simple diagrams, especially if you then chain them together. So if you've got digit defined in a different diagram somewhere else and letter defined in a different diagram somewhere else, you can see how you can have sort of different hierarchies of diagrams and end up with pretty complex definitions. Yeah, but if you like logic puzzles, you'll love syntax definition. This might be a sensible place to stop and allow you some chance to practice some of these BNF questions while it's all still fresh and you can focus on it, because they are a bit tricky, and it's worth spending some time just working through a couple of examples if you haven't done so yet.